All right, and here we are at section 2 of of chapter 20 of this particular unit. And this has to do with biomass and hydroelectric power. So, what is biomass? It's organic matter that makes up living organisms, in this case used for fuel. What are examples and non-examples of biomass used for energy? Examples include wood, manure, charcoal. Okay, guys, charcoal is different than coal. Charcoal is what happens when you have partially burned trees. And then also crop residues. Also, conversion to liquid automobile fuel. That's something we're going to talk about in a second. So biofuel, it's kind of a subset of biomass. And let's see, some non-examples are fossil fuels and uranium and solar and wind and water power. And what do we do with the biomass to get electricity? You burn it to boil the water, to create the steam, to turn the turbine, to turn the generator, to create the electricity. All right. Make a connection between a country's classification, developing or developed, and how it uses biomass for fuel. Also connect a country's classification and overall use of biomass for energy. Developing countries use biomass for heating, cooking, and lighting primarily. And developed countries use biomass to generate electricity and to create fuels for machines like cars. Developing countries use far more biomass per person and overall than developed countries do. Okay, and it's a renewable resource in developing countries until demand exceeds regrowth. And barren rings are created around villages as demand grows, and it can lead to all the things that happen when you take plants out of the ground. Soil erosion, desertification, foul water supplies. All right, and here in developed countries, you use it to generate electricity. You burn the fuel to boil the water, to create the steam, to turn the turbine, to turn the generator, to create the electricity. You can also use it to create fuels for machines like cars. You can use anaerobic processes to create ethanol and biodiesel. And also fuels come from two other processes called gasification and pyrolysis. And here you can see this biomass is lining up at a plant to go ahead and be turned into a type of fuel. All right, so let's go ahead and talk about ethanol. How is it generally made? By fermenting carbohydrate-rich biomass, like a specially grown crop, in a process similar to brewing beer. How is it used as an energy source? In the US, it's a gasoline additive. If you go to fill up a car, you're going to notice it says it's up to 10% ethanol. It basically stretches the gasoline. You can add that to up to 10% by volume. You can make that ethanol and then make the other 90% gasoline, and then you're basically making that last a little bit longer, basically. And then, okay, and again, up to 10%. Why? It's because if you bring in gas, you can make it so you don't have to buy as much. And it doesn't seem to, that up to 10% doesn't affect our internal combustion engines. If we were in other countries, ethanol is used straight as the main component of automobile fuel, but that requires a different type of engine than the ones that we've got here. And if you're looking at what these crops are, here on the left, this is corn, here on the right, this is sugarcane. These are both commonly used to produce ethanol. On the left, the corn most often is in the US, and then on the right, the sugarcane, that's Brazil. All right, ID the country currently running the most automobiles on ethanol. That would be Brazil. They're going to be at almost 100% cars running on ethanol here real soon. Okay, what is biodiesel made from? Vegetable oil. You can collect it from a fast food place, purify it. It doesn't take much to convert a regular diesel engine to biodiesel and then run your car or bus. Then you're keeping the stuff from going into a landfill. All right. Identify ways that biomass can be used directly and indirectly to produce electricity. Directly, you burn it to boil the water to create the steam, to turn the turbine, that turns the generator, that creates the electricity. Or you can use it in co-firing. This is also considered a direct method. You use up to 15% by biomass with coal to kind of stretch the coal without decreasing your heat output. All right, indirect, you can decompose biomass to produce methane. Remember, that's natural gas. that can then be burned to generate electricity in the usual way, which is up there. And then up there on the slide. And let's see. Also, in another indirect way is gasification. You vaporize biomass at extreme temperatures in the absence of oxygen to again create methane, or eventually produce other things like methanol. Pyrolysis is similar to gasification except that it produces a liquid fuel as opposed to a gas. Alright, and here's what pyrolysis looks like. You're welcome to pause anytime here and take a look at this more in depth. Pros and cons of biomass. Pros is that it's carbon neutral, which means that the carbon dioxide that's released during combustion is the same as the carbon dioxide that's taken in during the growth process, because remember, plants during photosynthesis take in carbon dioxide. It's renewable as long as the biomass sources are not over harvested. There's, let's see what else I have on here. Yeah, that's all that your book lists, but think about all the other stuff. There's not any impurities like mercury. You have fuel supplies in more areas. It reduces our dependence on foreign fossil fuels. For those folks who can't get behind the granola eating, hemp wearing, super crunchy green liberals or whatever who are into green power, think about it like this. It reduces your dependence on foreign fossil fuels, on countries that don't particularly care for the United States. Plus, by cultivating biomass, let's say in the United States, you increase jobs, and then you also, it increases homeland security, because if an outside source of fuel gets cut off, that's kind of a problem. And, okay, so, cons. This is, your textbook doesn't ask for this, but it's always good to think about pros and cons. Oh, actually, for environmental drawbacks, my bad. Let me go ahead and go through number 9. How is fossil fuel use still a part of the biomass production? Fossil fuel-run vehicles still are needed for farming processes. Fossil fuels are needed to run the water pumps to water the grass. Fossil fuel vehicles take biomass to the power plants where they're used to create electricity, yada yada. But it's still less. And at some point, all of those things could be replaced with another source of energy. Okay, ID for environmental drawbacks to using biomass for energy. Indoor air pollution when it's used in traditional ways. A lot of countries where it's burned for, again, that heat and that light, they don't have chimneys. And so people are breathing in, that's the ash. Over-harvesting of fuel wood, the usual issues like deforestation, soil erosion, desertification, diminishing biodiversity, destruction of habitat, fouling of water, blah, blah, blah. And then cultivation of novel biofuel sources have all the drawbacks of monocultures. And then growing bioenergy crops also requires substantial inputs of energy. You have a really low EROI. You don't get a lot of investment back. And it's also land intensive. You're taking away land from where you could grow food crops. All right, here is a switchgrass farm. Switchgrass grows incredibly quickly, and it doesn't take a lot of, let's say, pesticide or fertilizer to grow, and it can be used as a source of biomass to create electricity. And here you can see it's being harvested and taken to a plant to create electricity. All right, how does the EROI for corn-based ethanol compare to the EROI for fossil fuels? Well, take a look. It's much lower. You only get like 1.5 units of energy for every 1 unit of energy that you invest. However, one of the things to start embracing as you're listening to all of this is the fact that we don't have to go with just one source of fuel. You can diversify your power grid, so a little bit comes from here and a little bit comes from there, and you do what's best for your particular area. Why are we not doing that right now? Because we're not. All of our infrastructure is based around fossil fuels. We would have to do a lot of retrofitting to make that kind of diversification possible. All right. However, let's go ahead and talk about hydroelectricity, which is through a dam. Describe how a dam produces energy. Water is led into a constricting pipe to speed it up. When you take a large pipe of water and you make its diameter smaller, one of the results is you make the water go faster. So you then have it pass over a turbine to turn it. So the turbine turns, that turns the generator that creates the electricity. So here's how that works. And you can see, by the way, that the ERI is pretty darn high for hydroelectricity. So here's how that works right here. And you can see, again, you should immediately be thinking, there's no air pollution here. There are only a couple of The drawbacks to the dam are, of course, you have biomass building up back here, so you can have anaerobic decomp, which produces methane, and then any natural sediments that's supposed to go downstream don't get to go downstream, and fish that are trying to migrate, it's kind of a problem. Also, this water will be heated up a little bit once it comes down here. Then you're just messing with the natural flow as well. If there's supposed to be flooding, to go ahead and put natural amounts of silt, which is nutrient-rich medium grain soil, onto the banks, that's not going to happen here. But again, the pros are no air pollution. And basically, once you get it set up, you're done. And remember, as always, with everything, when you build a dam, fossil fuels are involved in that building process. All right. Describe how the run-of-river technique produces energy. A portion of the stream is diverted to create electricity, then rejoins the rest of the river downstream. And you can see you avoid a lot of the problems that I talked about before. Here's the traditional hydroelectric plant, and then here's the run-of-river. Pros and cons to using hydropower. Pros, again, no air pollution. It's renewable. It's efficient. Cons are it does destroy habitat. You have flooding upstream and lowered water levels downstream. It blocks both fish migration and travel of sediment. You have buildup of organic matter behind the dam, and then thermo pollution and shocks, because this water that flows out of here is much warmer. One of the drawbacks to run-of-river is, you can probably guess, you're not producing near as much electricity as you are with these hydroelectric plants. But a pro is these rivers don't have to be that big. So let's say you have a rural area where you only have like 20 homes and it's near a pretty good rushing stream. You can go ahead and have all your power. Another con is, remember that these things are usually powered by snow melt running downhill. So if you don't have snow melt one year, you got a problem. All right, so which country is the top producer of hydropower? Feel free to stop and look at this, but we talked about it already. It's China. What is the name and location of the world's largest dam? That would be the Three Gorges Dam in China. Here are the impacts on the environment. You can see the flooding, and then a lot of the changes to the deforestation and all that other good stuff. All right, and that is the end of section 2.